You know, it feels like every couple of months, a new AI model drops that just completely shatters what we thought was possible. It's moving so fast, it can honestly feel a little bit like magic. But what if I told you that this incredible progress isn't magic at all? What if it's predictable? Okay, let's really get into this.
This is the question, right? How are companies like Anthropic and OpenAI pulling this off? How do they keep releasing these models that are just consistently, unbelievably better year after year? Well, the answer lies in this really powerful, kind of hidden principle that's turned the art of building AI into something that looks a whole lot more like a science.
And to understand this, we're going to turn to Jared Kaplan, one of the co-founders of Anthropic. Now get this, Kaplan didn't start in AI. He was a theoretical physicist trying to find these big, simple, elegant laws that explain how the entire universe works. And he brought that exact same mindset to AI, asking the biggest, simplest questions. And the answers he found, they pretty much changed everything.
All right, so to get to the secret sauce, we first need a super quick refresher on how these models, like Claude and ChatGPT, are actually built. Fundamentally, you can think of it as a two-step process. First up, you have what's called pre-training. This is where the AI model just gorges itself on a massive amount of text from the internet, from books, from articles, and its only job is to learn one simple thing: predict the next word. That's it. But by doing that billions and billions of times, it develops this deep, intuitive grasp of language and concepts. Then comes step 2, reinforcement learning. This is where actual humans come in. We chat with the AI, we rate its answers, and we tell it, hey, that was helpful, or nope, that was wrong, or that was harmful. And that feedback loop is what fine-tunes the model to be a useful and safe assistant. So those are the two phases. Pretty straightforward. But here's the aha moment. This is where it gets really interesting. Researchers, with Kaplan leading the charge, they discovered this stunningly precise relationship between the effort you put into training and the performance you get out. They gave this relationship a name: scaling laws.
And you can hear the surprise in Kaplan's own words here. He says they got really lucky. I mean, no one expected the messy, ridiculously complex process of training a neural network to follow such clean, predictable rules. It was this discovery that gave everyone the confidence to bet big. I mean, bet billions of dollars on this whole approach.
So what is this magic recipe? Well, the scaling laws basically showed that if you systematically increase 3 key ingredients, you get more computing power, you feed it more data, and you build bigger models, you get a predictable, almost guaranteed improvement in performance. It's not just a vague more is better idea. It's a formula. It's if you add this much more compute, you'll get this much smart. And this is the part that is just wild. The trend lines they plotted were so perfectly straight, across huge scales, that they look like something you'd find in a physics textbook describing gravity or planetary orbits. It was a signal, clear as day, that as long as they could keep scaling those 3 things, the AI was just going to keep getting smarter. The path forward was clear. Now, this whole predictability thing doesn't just apply to that first phase of training, but to understand this next part, we need to quickly define something called an ELO score. You probably heard of it from chess or other competitive games. It's just a rating that tells you how likely one player is to beat another. Well, in AI, we use it to measure how often humans prefer one model's answer over another's. And here's the kicker. Researchers found out that the second phase, that human feedback part, also follows scaling laws. It's not just the pre-training. For example, in a study where an AI learned to play the board game Hex, its ELO score improved in a perfect, straight line as it played more and more games. This was huge. It meant that both phases of AI training were basically a crank you could just keep turning for better and better results.
Okay, so we know how AI is improving so predictably. We have the scaling laws, but so what? What does that actually mean for what AI can do? What new things is this steady march of progress actually making possible right now?
Kaplan suggests thinking about AI's growing power along 2 main axes. Think of a graph. The y-axis going up is flexibility, the AI's ability to handle more than just text, to see images, to hear audio, just like we do. And that's super important. But Kaplan argues the x-axis, the one going out to the right, is the really interesting one. He calls it the time horizon. This measures how long of a task the AI can reliably handle, from a 5-minute coding problem all the way to a multi-hour complex project. And this time horizon, it's expanding at a jaw-dropping rate. According to a study by Medicare's, the length of a task an AI can reliably complete from start to finish is doubling roughly every 7 months. Just let that sink in for a second. This is exponential growth in action. A few years ago, we were wowed by AIs doing things that take a few minutes. Now they're starting to tackle projects that take hours or even days. This is where things get truly transformative. So this brings us to a really key difference in the shape of human intelligence versus AI intelligence. Think about it like this. A human music critic can tell you exactly why a symphony is brilliant, even if they can't compose a single note themselves. Our ability to judge is often way higher than our ability to create. For today's AIs, that gap is much, much smaller. Its ability to judge if an answer is good is still very closely tied to its ability to generate that answer in the first place. And that's a big reason why human oversight is still absolutely critical.
So what's still missing to get to that next level? Kaplan points to a few key ingredients that we need to bake in. First, organizational knowledge. The context to actually work inside a specific company or on a team. Second, memory. And not just remembering facts, but remembering the state of a long, complex project over time. And third, and this is a big one, better oversight. The ability for us to give feedback on really nuanced, fuzzy tasks. Things like telling a good joke or having good taste, where there isn't a single correct answer.
So, given this predictable, relentless march forward, how should we be thinking about building for the future? How do we not just keep up, but actually get ahead of this curve?
Well, Kaplan has 3 key pieces of advice for anyone building in this space. First, he says build things that don't quite work yet. Because the models are getting better so predictably fast, what seems impossible or clunky today might be totally trivial in a year. Second, use AI to speed up the process of integrating AI itself. It's a feedback loop. And finally, find the next green field. Software engineering was the first big wave of adoption. What's next? Is it law? Is it scientific research? Finance? That's the race that's on right now.
So this is where we land. The story of scaling laws tells us that the future of AI isn't some complete mystery. It's a curve. We can see the direction it's heading. And that means the question is no longer if AI will become more powerful. The real question is for us. It's a challenge to all of us. If you know the future is coming down a predictable path, where on that curve do you want to place your bet?